So before talking about WAN technology like NAT and VPN, GRE and IPsec, let's understand whatever things we have covered till now, like how to design LAN, local area network, right? And what is network architecture. So guys, you know, we always design network in architecture, right? And the most common used architecture is three-tier architecture, where we have access layer, distribution layer, and core layer. At access layer, you are going to use access layer devices, means layer 2 switches, right? And the purpose of access layer is to connect all end devices together, right? And at access layer, we can create VLAN to separate the traffic, because the real requirement of businesses or the enterprise network is what? Right? Connectivity first issue. Scalability. Network should be scalable, means easily they can add some extra clients, some extra employees. All should be able to communicate with each other. All should be able to access the resources. Maybe resource belongs to same branch or different branch, not matter. Some employees should have remote access, remote VPN, right? And at access here, you are going to connect all end devices together. End devices means your PCs, your servers, right? Like in the network, you can have DNS server, you can have HTTP server, right? You can have multiple application for the application of your company. You can have IP phones, you can have printer here, right? You can have IoT devices, right? You can have some wireless devices as well, like the mobile devices. And then at access layer, you will have two types of device, right? Layer 2 switch and access point. By the way, access point also works at layer 1, like where your end devices are working. And then to connect multiple access layers, like multiple department, to aggregate multiple department, right? Because here at access layer, we have connected all the end devices. Now in the company, we have multiple types of traffic, right? Maybe this is my HR department, this is the another department, let's say finance department, right? This is, let's say, like what we can say sales department, right? Like this, we can have admin department, server department, where we have lots of servers. So these are different types of users. So for network, these are different types of traffic. Why we need to differentiate, why we need to separate each type of traffic? So that we can configure what, guys? Policies. Means according to our requirement, we can configure the policies. We can, like if you want that HR users should not be able to access internet, they should be only able to communicate with each other, or they should be able to access the internal server, right? So if you don't want to provide internet access to HR user, first you have to separate the HR user from the network. And for the separation, we are using VLAN, right? The most important thing at access layer is segmentation only. Segmentation, which can be done with the help of VLAN. Segmentation means dividing large network into a smaller network. So let's suppose at each department, in each department we have 200 users. Here we have 200 users, right? In each department we have 200 users. So total number of user and devices are 600, right? And guys, we can use multiple switches to connect 600 computers together. I can have multiple access layer switches, as well as I can have some wireless access point also to connect wireless devices together. And then we can divide that large network into a smaller part according to our department, according to our traffic. And once you have divided, you have segmented the network, now you can configure the security for a specific department, for a specific type of traffic. You can configure quality of service, you can configure internet access, you can limit internet access as well. Like on the internet everything is available, but if you want, HR users should only be able to access the Google server, nothing else. So you can limit the access as well for a particular department. So that's why segmentation is very important at access layer, and we done segmentation with the help of VLAN, right? Now how, if we have separated, if we have divided the large network into a smaller part, then how all the smaller parts are going to communicate with each other? So we need to configure inter VLAN routing, right? And we'll configure inter VLAN routing on distribution layer switch, which is aggregating all the department together, right? So here distribution layer is responsible to aggregating all the departments. So here for the inter VLAN routing we have two options, either I can use router on a stick method or I can create SVI, right? So for all the VLAN we can create SVI, switch virtual interface, for VLAN 10, VLAN 20 and VLAN 30. And then we have high-end devices, high configuration devices at core layer, right, which is responsible for internal and external routing, right? Let's suppose this is one side of a company, one side of a company. So like this, if you have multiple sides, so your core router is responsible for the communication between multiple sides, that is external communication. This core router is responsible for internet access to all the end devices, right? So at core layer we need good devices, right? We need good RAM, because it is going to handle lots of traffic. See, this switch is going to manage, guys, 200 users traffic, right? But this switch is going to perform routing for 600 users, and this device is going to manage maybe 6,000, 10,000, 1 lakhs of users when we are connecting multiple sites together. So here we need high-end devices at core layer. This is generally core layer, right? So if I will talk about the configuration at distribution layer, so at distribution layer we will configure inter VLAN routing, right? We are configuring inter VLAN routing on distribution layer switch. IVR, we are creating like IVR with the help of SVI. We can configure DHCP service here so that my end devices can get IP address, right? And then we can configure routing here. Routing, why routing? Because between distribution layer switch and your router we need what? Routing, because by default router don't know about this subnet, the subnet which you will run in this department, in HR department, in sales department and in VLAN department. So here we have to configure the routing protocol so that the switch will advertise all internal prefixes to edge router core layer. So these are the basic configuration on distribution layer, and then at core layer we have to first configure internal routing, right? This router should have route for all the internal departments. Then here we have to configure NAT. Why NAT? Because, guys, this is public network and this is your private network, right? The IP address which you are using over here is private, but the IP address here we are using is public. And by default communication between private and public is not possible. So the technology which we are using to make it possible, like to make communication possible between private and public, we are using a technology called NAT, network address translation. So with the help of NAT we can access internet from the inside. When I will have multiple sites like R2, and then again R2 is connected with distribution layer and access layer, and this router is also connected with internet. So now between, say, both internet are directly connected with each other. So between R1 and R2 then we have to configure VPN, like the logical network, virtual private network. So these are what? These are WAN technology, NAT, VPN, GRE, IPsec, and we have to configure one default route as well towards ISP. So today we are going to focus over here only, right? Before that, I am expecting you are good enough with the access layer, distribution layer, and core layer devices configuration, right? Like how to create VLAN. Even you can plan for IP addressing, right? Like if you are network engineer in a company and this is the requirement of a company, right? So how you are going to plan for IP addressing? So like you can see in each department I need 200 users. So I can elect one main subnet. Let's say my main subnet is main network. My main network is, for an example, 192.168.0.0/16, right? So after subnetting we can get this subnet 192.168.10.0/24. I can use it for HR department for VLAN 10, right? The another subnet 192.168.20.0/24. I can use it for VLAN 20. 192.168.30.0/24 I can use for VLAN 30, right? Or I can use .1, .2, .3 like that also. .1, .2 and .3. You need one subnet between your distribution layer switch and router and the public subnet. You have to purchase the public IP address from your local ISP. So as we know, we need 200 IP addresses and my network should be scalable. Means there should be few more IP addresses in the network, right? Some extra IP address should be free in each subnet. So with /24 we'll get 254 valid IP addresses. We'll use 200 IP addresses. Still we have 54 IP addresses in each department. So we can scale it later. So this can be the IP planning. Clear? Any question? In the network design, the most important part is segmentation only, dividing large network into a smaller. Then the traffic management, how you are going to manage the traffic. Like if you have segmented the network, then you can configure the quality of service. Means you can prioritize some traffic. You can prioritize voice over IP traffic. We can configure one separate VLAN for voice. Let's say my VLAN 5 is my voice VLAN. Voice VLAN. So I can add all the IP phone in this VLAN and then we can configure quality of service. We can prioritize VLAN 10 over all the other VLANs, right? Like you might have seen, we are prioritizing voice traffic over data traffic, over the video call. Yes or no? After that, the security is also important. Security, for security we can configure ACL here, right? With the help of ACL we can limit the access of internet, we can limit the access of our server. And after that, the most important thing is redundancy. Like in this network you can see I don't have redundancy at distribution layer, at core layer, and for the ISP. If ISP or core layer or distribution layer, any device will goes down, then connectivity will goes down, right? So here at each layer, distribution layer, we should add one mode device. At core layer, we should add one mode device. We should have connectivity from multiple ISP, and then we can use BGP protocol between ISP and core router. If we have only one connectivity from ISP, then definitely I will configure the default route, right? And after configuring the network, when your network is live, then you are going to set up the monitoring tool, monitoring and maintenance tool, through which you can check the health of your devices. You will be keep checking the health, right? And if I will talk about the real time guys requirement, right? So in real time your requirement will be always updating, right? We will be regularly monitoring the network, and regularly we will be updating the policy, right? It might be possible that my policy is going to be different on weekdays and it will be different on weekend, right? So here we can integrate the firewall as well between the core router and ISP, or we can integrate the firewall between router and firewall as well, but you should not replace this router with firewall. If you are thinking, Praful, what if I will connect one firewall directly here? So guys, the primary function of firewall is security, right? But in this scenario, if I have only firewall, then firewall have to perform routing as well, right? Then firewall is responsible for routing as well and for the security as well, right? So it might be possible you will get lower performance. So for the specific task, we have specific devices. For the routing, we will be using routers. For the security, we will be using firewall. For connecting end devices, we will be using layer 2 devices. For connecting end devices wirelessly, we will be using access point. And after that, to connect multiple access layer devices together, we will be using layer 3 switch, distribution layer switch. And to connect LAN and WAN, we will be using core layer devices, high configuration devices, that is router. Got it, guys? Yeah, go ahead. You don't need to raise hand, you can directly speak. If the company has 3 different ISP, how they can connect or manage with router? Yeah, it will manage, you will see. Yes, brother Amar? No, you can. You can. Both are correct way. Both are correct way. Here also we are placing, and here also we are placing. Both. Even you can place here also. Here you can connect it to switch, and then you have to configure the scenario in such a way, like when this PC want to access internet, so first they will send traffic to firewall, then firewall will inspect the traffic. Inspect means it will check the policy is there. If the traffic is allowed, then firewall will forward it to internet. When internet will generate reply, it will reply to firewall, and after that firewall will send it to user. So this will be your packet flow. Anywhere you can add firewall, all are the correct way. Everything depends on our requirement. Most of the time you will see firewall here. That is the most easiest method to configure and integrate the firewall, right? That's why. Maybe if you are adding firewall here, you need more skillful engineer to set up it. Anything else? So now I have no any redundancy for ISP. Later I will add one more ISP here, right? Then I will connect it to router. And after that I will add one more router here also, and will connect like this. Right? So if you know how to configure the 2 ISP, then you can configure 3 ISP also. Okay. So guys, now let's begin. We are not going to discuss this site, only I will show you the configuration in the inside network. Mainly I will focus on this router, edge router. Even on ISP router, I will only configure the IP address, nothing more than that. Now let's understand the NAT, network address translation. NAT. So guys, first question is, why NAT? Why NAT? Because private and public networks can not communicate with each other. Now, your question should be, Praful, why private and public cannot communicate with each other? What is this rule? Is it valid question? Yes, it is valid. So see why it will not communicate, because when you will purchase connectivity from the ISP, ISP will provide you the public IP address which you will configure here on your WAN interface. Now you are not allowed to advertise any network to ISP. Like if you are thinking that here I can configure OSPF protocol and after that through OSPF I will advertise this submit to ISP. So no, you are not allowed to configure routing between ISP and router. If you want to configure the routing, right, then you have to connect with ISP with your requirement, right? You have to, if you are going to run BGP, you have to purchase ES number also, right? Then ISP is going to configure BGP on their interface, right? And after that also you will be allowed to advertise a specific prefixes, right? Right. You can advertise prefix with /24 with /25. You cannot advertise /26, 7, 8, 28, 29, 30, because here we have lots of IP address. Otherwise, just think about it. Like if all the companies are going to advertise their internal network to ISP, then the routing table size of ISP router is going to be very large. First issue. Second issue, we cannot reuse the private IP address. Guys, total length of IPv4 address is 32 bits. Means how many total number of IPv4 addresses we have? 2 to the power 32. But we need more than this IP addresses. This is not sufficient. So that's why what we did, we divide IPv4 address into two parts, private and public. Why we divide? To reduce the shortage. How we can reduce the shortage? By dividing the IP address. See how we can reduce the shortage. Now we said anyone can reuse the private IP address, right? Within the organization you have to use same IP address, but the another organization can use same IP address. How it is possible? It is possible only on one case, if ISP routers are not going to forward traffic on the basis of private IP. So this is happening. ISP is not going to forward traffic on the basis of private IP. So whatever public IP address you have purchased from the ISP know your entire network through that public IP address only, right? Like here IP is 1.1.1.1. So ISP know your entire network with this IP address or maybe with this subnet. Yeah. You can configure the BGP. If you have multiple ISP here, ISP2, then can you achieve load balancing between ISP1 and ISP2 with the help of default route? No. To achieve load balancing here between ISP1 and ISP2, I have to configure BGP, only and only BGP. Yes, definitely. Right? We'll implement the BGP here, na bro? You will purchase, like your company, yes, your company enterprise will purchase, right? Even like right now you are using internet, if you have broadband connection, then that means you have purchased the public IP address from your ISP. Now let's say in your home there is one server and you want to provide access to this server to outside user. You can configure NAT with default route. Now your company has grown. Now you need 1000 number of servers and multiple ISP. So you have to purchase the ES number. You have to configure the BGP for the load sharing, right? One gateway cannot handle all the traffic. One gateway cannot handle all the traffic of Netflix, Google server, YouTube server, Facebook server, Instagram servers. We have to here loads here on multiple servers as well as on multiple ISP. So whenever we have the requirement, we have to purchase it. How you will purchase? You will purchase from your local ISP. How your local ISP will get the ES number? They will get from tier 2 ISP. How tier 2 will get? Tier 2 will get from INA. You know na RIR. So RIR will provide you the public ES number, public IP address, public ES number, everything. Which one? This is a part of routing and switching. No. In network designing, the first topic is type of topology. Design. First, we are going to understand the technology, how we are going to connect the devices physically. That is topology. Those are the part of network design. This is the part of routing and switching. Routing switching means connectivity. Right? So guys, why we come up with NAT? We come up with NAT to reduce the shortage of IPv4 address. How we can shortage? How we can reduce the shortage? By dividing IP address into private and public. And private IP address is reusable. Means I am using this subnet. Maybe another company is also using this subnet, same subnet. Right? Then also they can communicate. Reason ISP. Both are connected through ISP and ISP knows our network with the help of public IP address. Right? So generally on the ISP interface you will find ACL, access control list, which will be blocking all the private IP address by default. Right? So you cannot reach to internet with the help of private IP address. Before forwarding traffic to internet, this router, your edge router, have to translate the source, because source is the private. When I will ping to Google, right, when I will type www.google.com in the browser, my computer is going to generate traffic for Google. Source IP will be the IP address of PC and destination will be Google server IP, which is the public IP address, right? And again, you are accessing the Google server through public IP address, but actually Google server will have again private IP address. Same way, here is the Google server. Here is the Google server, and Google server is also connected with edge router, right? And that edge router is connected with internet. They are using public IP address here, and through this public IP address you are accessing this internal server. So on the internal server again they will be using private IP address, but you are not aware about the private IP address of Google server, right? So it will generate traffic, destination will be public, it will forward to router. If router will directly forward to ISP, then ISP is going to discard it because source is private. So router have to translate source. Okay. So first thing is why we need NAT. So we need NAT for the translation, right? To avoid the shortage of IPv4 address, right? You can check the range of private and public in your notebook, book, Google, anywhere. Then what is NAT? NAT. So NAT is same like the which provide the solution of this. Private and public cannot communicate. That means NAT is an process which makes communication possible between private and public IP address and vice versa, right? Now third question is how NAT works. So NAT always translate source IP address of request and public IP of reply message. That means when PC will generate traffic for internet, right? So when request will reach to router, router is going to translate source. When ISP will generate reply, it will generate reply to public IP address because source is going to be public. So when router will receive the reply message, that time it will translate public into private and then it will forward to router. Right? And guys, to understand NAT, you have to understand the first zone. Right? And there is one best PDF for NAT. You can use this one. So here also you can read what is NAT. In the storage available of IPv server in response, a specific subnet of IPv4 address space was designed as private to the temporary alternative to this problem. A public IP address can be routable on the internet, thus that must internet accessible must be configured with public addresses. Allocating of public IP addresses is governed by the internet INA, and a private IP address is intended for the internal use within a home or organization and can be freely used, right? So private, the difference between private IP address and public IP address is, first difference is in terms of range, then in terms of free and paid, and routable and not routable on the internet. Private is not routable, public is routable. And through BGP we can route the private also. Through BGP we can advertise private. We'll see that, right, how we can configure it. And these are the range of private. So from class A 10.0.0.0 to 10.255.255.255.8, all the IP addresses are private IP address. So guys, if I have one IP address, let's say 10.100.100.150, so is it on private IP or public IP? It is a private IP. Private IP address. And if I have one IP address from same class, from class A, which is 11.10.12. Let's say 13.12, is it a private IP or public? It is an public IP address. Right? So range of private from class A is 10.0.0.0 to 10.255.255.255. This is the range of private IP address from class A, right? We can use, if our network size is very large, then definitely we'll use IP address from this class. Then class B range 172.16.0.0 to 172.16.255.255 from class C, right? And it is possible to translate between private and public address using NAT. NAT allow a host to configure with private IP address to be stamped with the public IP address, thus allowing that host to communicate across the network. It is also possible to translate multiple privately addresses host to a single public IP address. Yes, we'll see that. That is types of NAT. So here you can read about NAT and then see type of NAT. Before talking type of NAT, let me tell you one more thing here. Like, I have one router here. This router is connected with internet and as well as inside network LAN switch. So here I have one switch, router and internet connected like this. R switch, and here I am saying iNet internet. So the IP address between your edge router and ISP will be public, right? So here let's say my subnet is 1.1.0/30, right? And here in the LAN my subnet is 192.168.1.0/24, right? So there is one user, let's say, connected with switch whose IP address is 192.168.1.1, 192.168.1.1, and the gateway IP address is 1.100 for an example, right? So gateway is 192.168.1.100. On the Google there is some servers, let's say 8.8.8, which is your DNS 8.8.8. so we can create the loopback on internet with this IP address. Now let's suppose if this PC want to access 8.8.8, so what will happen? It will, let's say, ping to 8.8.8. so PC will generate ICMP traffic where source 192.168.1.1 and destination IP 8.8.8.8. what will be source MAC? What will be source MAC? PC MAC address, destination MAC will be the MAC address of default gateway, right? Then it will forward to switch, switch will forward it to router, right? Now how router will get to know that here I need to perform translation? See guys, before translation, to forward traffic to 8.8.8.8, router should have what? Route in the routing table, because you know the behavior of router, like how router treat the traffic. Whenever router will receive the traffic, first it will check layer 2 information, right? At layer 2 information it will check destination MAC. If destination MAC will match, then only it will accept, otherwise it will discard. In two cases it will accept: if destination is broadcast or destination is router MAC address. So destination MAC will be the MAC address of router, it will accept at layer 2, it will remove layer 2 header, then it will check layer 3 information, IP header. In IP header it will check IP, destination IP 8.8.8.8, it will compare destination IP address with the routing table, it will run command, so IP route, right? So is there any route available on router for 8.8.8? No. And like 8.8.8 we can have multiple subnet on the internet, so we cannot configure route for all the subnet for the internet, right? So better to configure one default route on router number 1 towards internet. So here we will have one default route 0.0.0/0, right, towards ISP. So this time router have route for 8.8.8, it will forward traffic to internet, right? So if router will directly forward traffic to internet, what will happen? Internet router will check layer 2 information, layer 2 information will match, again it will remove the layer 2 header, it will check layer 3 information. In layer 3 it will say, okay, destination is 8.8.8, it is my IP address, so internet router will generate reply. When internet router will generate reply, then source IP will be 8.8.8.8 and destination IP will be, guys, 192.168.1.1. yes or no? Now to forward this traffic, internet router is going to check routing table. In routing table it will compare destination IP address. So will route available in the routing table of internet router? Answer is no. So internet router is going to drop the traffic. This is the by default behavior before configuring the NAT. So before configuring the NAT, after default route, if you will ping to internet 8.8.8, right, traffic will reach to internet, but internet cannot forward the reply message. So what will happen after NAT configuration, and how router will get to know that with which type of traffic I need to perform translation, right? So first of all, guys, we are going to define the John on this router. Like I have to tell to this router that, bro, this interface is your inside interface. This interface is your inside interface. Means inside interface means the LAN interface, which is connected with LAN devices. And then I have to say your this interface is outside interface, means WAN interface connected with internet. So first of all we will define John, which interface is inside, which interface is outside. Now whenever router will receive traffic on inside interface, what I am saying, whenever router will receive traffic on inside interface, it will check the NAT rule. It will check NAT rule. And in NAT rule, we are going to define which rule? We are going to define a rule like translate 192.168.1.1 to 1.1.1.1, which is the WAN interface IP address. Let's say this is my NAT rule. Okay. So now when router will receive the request message, it is going to translate source 192.168.1.1 to 1.1.1.1, and destination is going to be exactly same, which is 8.8.8.8. How it will get to know about the translation? It will get to know about the translation with the help of inside interface, right? And then router will check again routing table and it will forward traffic to internet. This time internet will generate reply for 1.1.1, right? Source will be 8.8.8 and destination will be 1.1.1.1, and then internet will forward it to router. Now router have already knowledge that I had translated 192.168.1.1 into this public IP address, so now I have to revert it, right? So what it will do, it will again translate 1.1.1.1 to 192.168.1.1, and then it will forward to switch, right? So the most important thing is defining inside interface and outside interface. Your LAN interface is nothing but the inside interface. On firewall also, you have to define the first John, right? Once you will configure inside interface on firewall, it will automatically configure higher security level, right? It will get to know that now I can trust on this interface, but outside interface, it will set security level 0. It cannot trust on outside interface. So by default, all the traffic will be allowed on inside interface, but not a single traffic will be allowed on outside interface. By default behavior of firewall. Got it? So this is how NAT will work. Then types of NAT. Why we have multiple types of NAT? See guys, I am going to design here 3 requirements. One router here connected to internet. Here I have one switch, and then here I have lots of users. First requirement. Second requirement, again here I have internet, I have one router, I have one switch, and here I have some servers. Let's say server, one server. Okay, let's say these 2 requirements. Requirement in the first scenario is all the users should be able to access internet, and requirement in the second scenario is all the users from outside should be able to access the internal server, right? Requirement over here is all the users should be able to access internet, right? And requirement over here is server should be able to access internet as well as outside users should be able to access server, right? So in scenario number 1, in first scenario, we need what? Unidirectional NAT, right? Means user should be able to access internet. Internet should not be able to access the user. Here you need to configure unidirectional NAT. NAT in only one direction, right? For which direction? For the traffic coming from inside to going outside. But in second scenario, I have to configure bidirectional NAT, right? Users should also be able to access internet, and internet should also be able to access server, right? So guys, for bidirectional NAT, we have a static NAT. A static NAT. This is, it is 1-to-1 NAT. Means 1-to-1 NAT means one private IP address will be always translated into one public IP address, right? Fixed private IP address and fixed public IP address. It is 1-to-1 translation, right? 1-to-1 translation means one private IP address will be translated into single public IP address, right? It is bidirectional NAT. It is bidirectional NAT means you can also access internet and internet can also access you. Now let's come on here. In this scenario, we have two types of NAT. One is dynamic NAT and another option is PAT, port address translation. First, understand dynamic NAT. What is dynamic NAT? So dynamic NAT is one to many translation. One to many translation means one IP address, not one to many. We can say many to many translation. Means many private IP address will be translated into many public IP address, right? Means here we will have multiple public IP address. Multiple public IP addresses are required. Here in second scenario, we need one public IP address for one private IP address. Here we need multiple public IP address for multiple users, for so many users. Maybe for 100 number of users we need 2 public IP address or 4 public IP address. And you know the group of public IP address is called pool. So we need pool of IP address. We need pool of IP address means public IP address. Pool of public IP address, and it is unidirectional NAT, right? Unidirectional NAT. This is what dynamic NAT. So guys, in dynamic NAT we have to purchase public IP address with subnet 30/30 CIDR value 30. If you will purchase public IP address with /30, so how many IP address you will get? 2 only. One will be configured on ISP side, one will be configured on your edge router, right? So here we cannot configure dynamic NAT. You can configure the dynamic NAT, but you have only one public IP address. Means at a time only one user can access internet. Let's say I have purchased IP with /30, right? And my subnet is 1.1.1.1, right? So IP address over here is 1.2 and IP address on my router is 1.1. I have configured the dynamic NAT over here, and in the LAN my subnet is 192.168.1.1. IP address of PC1 is, let's say, .1. IP address of PC2 is .2, right? So when PC1 will generate traffic for 8.8.8, what will happen? It will forward traffic to router, and router is going to translate source IP address means 192.168.1.1 into 1.1.1.1. What will happen if at the same time PC2 will also generate traffic? Router will discard it. The reason, there is only one public IP address available in the pool, which is already occupied. which is already in use. So there is no free public IP address available. So in the dynamic NAT, we cannot purchase this subnet. We have to minimum purchase /29, right? So if I will purchase, guys, /29, so tell me how many valid IP addresses are there? 6. If my subnet is 1.1.1.0/29, so how many valid IP addresses are there? 6. 6 IP addresses are there, right? Range is 1.1.1.1 to 7, right? So I am already using 1 and 2, right? So free IP addresses are 1.1.1.3 to 1.1.1.7. How many IP addresses are there free? 4, right? So I can create one pool of these 4 IP addresses pool. Now, how many user can access internet at a time? 4 user can access internet at a time. Not more than that. Yes or no? If 4 users are accessing internet at the same time, then 5th user cannot access because now free public IP address is not available. So guys, that's why we come up with one new types of NAT that is called PAT. PAT stands for port address translation. This is many to one translation. Many to one translation means many private IP address will be translated into single public IP address, right? Now even you can purchase /30 subnet, right? So you have one IP address over here and one IP address over here. Now all the users private IP address can be translated into single public IP address. Now your question should be, how it is possible, Praful? If let's say again user 1 have sent the traffic to internet, so 1.1 is already in use, occupied, how PC2 can access internet? So guys, what will happen now? Router is going to use port number. Router is going to use port number. It will assign one random port number with traffic, right? Like 192.168.1.1 is your source, right? And it have translated into 1.1.1.1. And it is going to add the port number also. Let's say source port is P1 and destination port is P1 and destination port is P2, right? One second PC will generate traffic. It will translate 192.168.1.2 into same IP address 1.1.1.1 and it will assign different port number. Let's say port number 3 source and port number 4 is destination, right? And when internet will generate reply, right? So in the reply, source IP will be 8.8.8, destination IP will be 1.1.1 and source port number will be what? Source port number will be P2 and destination port will be P1. So when my edge router will receive this traffic, it will get to know, okay, I am getting reply for port number 1, means I need to translate 1.1.1 into this private IP address, right? If the destination port is 3, then it will get to know, okay, I need to translate 1.1.1 into this private IP address. So in this way, router will start performing translation. So this is called PAT. So total we have 3 types of NAT: static NAT, dynamic NAT, and PAT. Whenever you have servers, you are running some services and you want to provide access to your service to internet through public IP address, you can use static NAT. We are not using dynamic NAT nowadays in the production network, right? We are using PAT here for one-to-many translation. So on a single router, we can have a static NAT also and we can have PAT also. Why PAT? PAT is for the general NAT, for the general translation, like requirement. All the employees should be able to access internet. We can configure one PAT rule, right? And most specific types of NAT rule will be the static NAT rule, which you will place on the top, right? So if both are running, static NAT and PAT, router will prefer to static NAT first over PAT. This is most specific NAT rule. Got it? So here you have same information. You can see types of NAT: static NAT, one-to-one NAT, dynamic NAT by using a pool of IP address, and then PAT, port address translation, that is also known as NAT overload. What we are saying, NAT overload to PAT. Translate the outbound traffic of client to a unique port number of a single global address. PAT is necessary when the number of internal clients exceed the available global address, right? Like in the dynamic NAT, as I told you, if there are 4 IP addresses, means only 4 user can access internet at a time. And let's say if more than 5 users are accessing internet, but they are not able to access, then you should replace the types of NAT. You should configure PAT there. Then guys, there are some terminology of NAT here, like you can see inside local. First terminology inside, second is outside. Inside means the internal interface, outside means the external interface, WAN interface. Inside LAN, outside WAN. And inside local means what? Inside local. And what it is? So NAT terminology as specified terms are used to identify the various NAT addresses, various types of NAT addresses, right? So inside local means the specific IP address assigned to an inside host behind the NAT, right? So whatever IP address you are running here, let me make it copy. What I am saying, see, I have on another side also, right? Or you can say this is my company and this is Google company, and both ISPs are connected together like this, right? So inside local means my internal network. It is talking about this network. This is what, guys? This is inside local, right? The private IP addresses behind the NAT is inside local. Then second term is inside global, the address that identify an inside host to the outside world. So whatever subnet you are going to run over here between your edge router and ISP, that is known as inside global. This is my inside global, inside local and inside global. And then outside global and outside local, again for here. This is the private network, so we can say this is outside local and this is outside global. Means outside private network of Google is known as outside local, and public network of Google is known as outside global. My private network is known as inside local and my public network is known as inside global. Is it clear? Outside global, the address is assigned to an outside host, usually a public address. And outside local, the addresses that identify an outside host to the inside network, right? Hope it is clear. So in NAT generally we will be using these terms, the global and local, public and private, means inside and global, local and global, inside outside and local and global, inside local, inside global, outside local, outside global, right? So for simplicity's sake, it generally accept to associate global addresses with public IP address and local addresses with private IP. Correct. Inside host are within the local network while outside host are external. See the diagram here. Also you can see inside local and outside. Inside local 10.1.1.0 or 10, this is the host IP address. Inside global 55.1.1.1. Outside global, the public IP address of outside 99.1, and outside local it is going to be this one. This is incorrect. Host A configure this IP address. Okay, you can ignore it. Then the configuration is there. So let's see the configuration. Can I start the configuration here? If anyone have question, please ask anything. Otherwise, let me start configuration. From where I should start the configuration, guys? From the access layer or from the ISP? From where you want to start the configuration? Access layer? Okay, just a minute. So on access layer switch 1, here I will use which subnet? Let's use 192.168.1.0/24 or 10.10.0/24. Here let's use 20.0/24. Okay, and here I am going to use, let's say, 30.0/24. Right, and the gateway IP address is, let's say, last IP address from the subnet is gateway IP address. Means on this switch I will create one SVI for VLAN 10, and IP address is going to be 192.168.10.254. for VLAN 20, 192.168.20.254, and for VLAN 30 we can have 192.168.30.254. and you can see the subnet between router 1 and distribution layer switch, and subnet between ISP and is router. And on the ISP I have one loopback. Yeah, go ahead. Anyone can explain it? Inside global means my public IP address. Outside global means remote site public IP address. If I have two branch, one is in India, one is in US, so at both branch we will have private subnet and public subnet. So my private subnet is inside local, my public subnet is inside global, and remote inside network is hello. Yes, and remote public network is outside global. Anything else? So on access layer switch, I am going to put all the interfaces in VLAN 10, but here I have to configure E0 by 2 as trunk, because we are going to configure inter VLAN routing as well, right? So this port should carry traffic of all the VLANs like VLAN 10, 20, 30. So interface E0/2 switch port trunk encapsulation dot 1q, and then we can say switch port trunk mode, switch port mode trunk, switch port mode trunk, and then we can say switch port trunk allowed VLAN, and like VLAN 10, 20 and 30, not like this, allow VLAN, and the VLAN ID 10, 20 and 30. So we are only allowing these 3 VLAN on this trunk link for the security reason. So this way we are configuring the trunk in real time. Do so run interface E0 by 2. Here is the configuration you can see. First I have defined the encapsulation protocol, then I have configured this interface as trunk interface, and then I have allowed these VLANs, right? Now we need to create these VLAN on switches, so I am going to say VLAN 10. Here I am going to define name like HR. If you want to configure name, if you want to avoid it, you can ignore it. Then VLAN 20 exit and VLAN 30 exit. Now interface range E0/0 and E0/1. These two interfaces are in VLAN 10, so switch port access VLAN 10. Now if you will verify here, so interface trunk, so you can see 0/2 is configured as trunk and allowed VLAN is 10, 20 and 30, right? So these VLANs are active in the management, but a spanning tree is running only for VLAN 10 because we have only interfaces in VLAN 10. Okay, then we can check so VLAN brief also. So here is the VLAN database. Now let me take you to switch number 2, access layer switch 2, and let's finish the configuration. Interface E0 by 2, switch port trunk encapsulation dot 1q, switch port mode trunk, and switch port trunk allow VLAN 10, 20, 30. Interface range E0/0 and E0/1, switch port access VLAN 20. Done. And one more thing, VLAN 10 exit, VLAN 20 exit, and VLAN 30. So we have created all the VLAN. So interface trunk, so interface trunk, on the trunk link all the VLANs are allowed, and 0/2 is configured as trunk. So VLAN brief, so we have the VLAN in all the VLAN in VLAN database. Let's configure access layer switch 3. Enable config T, interface E0 by 2, switch port trunk encapsulation dot 1q, switch port mode trunk, and switch port trunk allowed VLAN 10, 20, 30. Exit interface range E0/0 and E0/1, switch port access VLAN 30. And finally VLAN 10 exit, VLAN 20 exit, and VLAN 30 exit. So we are done with the access layer switches configuration. Let me configure one IP address on this PC4. Here I am going to say IP 192.168.1.1/24, and gateway IP address will be 192.168.1.254, right? In the same way on PC5 also you can configure one IP here, IP 192.168.1. What IP address I have configured here, 1 or 10? 1, so let me make it to 10. On PC, this PC also 10.2/24 and 192.168.10.254. Now these two PCs can communicate with each other. I am going to close the console of access layer switch 1 because it is not required, access layer switch 2 also, and access layer switch 3 also. Between these two PC you can verify the connectivity, like from here I can ping 192.168.10.2 and ping will work. You can see ping is working, right? Now for the verification I can create I can configure IP address on PC 6 also, and 192.168.20.1/24 will be IP here, and 192.168.20.254 is the gateway. But VLAN 10 and 20 cannot communicate with each other. The reason, guys, we need inter VLAN routing. So here you can see I'm not able to ping 20.1, right? The gateway is configured, but gateway is not reachable now. So let's configure the distribution layer switch. Let me access it. And first of all, here I'm going to configure trunk link. So interface range E 0/0 to 2, and here I am going to say switch port trunk encapsulation .1q, switch port mode trunk, and switch port trunk allow VLAN 10, 20 and 30, right? So interface trunk, so you can see all these interfaces are trunk and all these three VLANs are allowed over here. Next thing is I am going to create SVI, and before creating SVI we can create VLAN here, like VLAN 10, VLAN 20 exit, and VLAN 30 exit. Then interface VLAN 10, and here I am going to say IP address 192.168.10.254 255.255.255.0, which is the gateway IP address, right? And no set. Then interface VLAN 20, here also say no set, and IP address 192.168.20.254 and 255.255.255.0. Exit. Interface VLAN 30, say no set, and IP address 192.168.30.254 255.255.255.0. Done. So IP interface brief. So you can see IP configuration is done, and status and line protocol of all these virtual interfaces are up, right? So now end devices can ping to their gateway, like from PC number 1 I can ping to gateway, which is 192.168.10.254, and you can see I'm able to ping the gateway. Now let me try to ping VLAN 20 user 20.1, and this ping should also work. Now you can see ping is working fine. Means we have configured the inter VLAN routing. All the VLANs are able to communicate with each other. This is inter VLAN routing. If you want to configure here security, you can configure the ACL. If you want to block the traffic, if let's say I want to block the traffic between PC4 and PC6, so we can create the ACL on this switch as well. Next thing is we need to configure this link between router and distribution layer switch. So guys, by default all the ports of layer 3 switches are acting as layer 2 switch. So first of all I have to make this switch as layer 3 switch, then we can configure the IP. So again let me access distribution layer switch, and here config T, then interface E 0/3. Here if I will try to configure IP address, you can see command is not available IP address, right? The reason, this port is switch port, so I have to say no switch port first and then IP address. Now I can configure IP address, let's say 10.1.1.1, or I can configure 2 here or 1 on router number 1 and 255.255.255.0, right? Port is by default no set. So IP route, in the routing table you can see this is directly connected network and all the LAN networks are there. So IP interface brief. So I have configured one IP on this interface Ethernet 0/3. Now let me access the router and let me configure the IP on router. Say no here. And then enable config T interface F0/0, I think. Let me check. Yeah, 0/0. By default port is no shutdown, so say no shut, and then IP address 10.1.1.1 255.255.255.0, right? So IP interface brief. Now you can see the line protocol is up. That means I can ping to switch, ping 10.1.1.2. so ping will work. You can see ping is working. I am able to ping the switch, but can I ping to PC from here? Can I ping to PC? So IP route, no, route is not available. 192.168.10.0 or 20.0 or 30.0, those networks are not available in the routing table of router. So now guys, those prefixes are in the present in the routing table of distribution layer switch, right? So we need to advertise these all subnet to router. How we can advertise? We can configure any routing protocol. So tell me which routing protocol you want to configure here. Tell me guys quickly. OSPF? OSPF is fine. We should configure OSPF only. Most of the time you will be using OSPF in real time. So on this interface I am going to say IP OSPF 1 area 0, and then IP OSPF network I can configure point to point, right? And then interface range VLAN 10, then VLAN 20 and VLAN 30. On these all interfaces I am going to enable OSPF, IP OSPF 1 area 0. Now here you can check. So IP OSPF interface brief. So OSPF is enabled on all the loopback, all the virtual SVI's interfaces as well as on E0/3 interface. Here network is point to point, and on these all interfaces network type is broadcast. Now let's enable OSPF on router, on edge router R1. Config T interface F0/0, say IP OSPF 1 area 0. Now we will have OSPF neighborship and network type also F0/0 IP OSPF network point to point, right? And so IP OSPF neighbor. So now you can see we have neighborship, right? That means so IP route OSPF, right? So you can see now I am learning these all subnet through OSPF routing protocol. So now I can ping to PC, like ping 192.168.10.1. you can see I am getting reply, right? Ping is working fine. Now let's configure the WAN link, right? So guys, on the WAN port interface F1/0, say no shut. Here we can configure the description also, like we can say connected to internet, or you can say WAN interface. Then IP address 1.1.1.1 I am configuring router 255.255.255.0, and I will configure 2 on ISP router. So on ISP router, let's configure the IP. On ISP router I will only configure the IP. If you want, you can block all the private IP addresses. Like, see what we can do here. Config T interface loopback 1 IP address 8.8.8.8 255.255.255.255 exit, and interface F0/0, say no shut, and IP address 1.1.1.2 255.255.255.0, right? Ping 1.1.1.1, and you can see I am able to ping internal router, right? Now can internal router R1 ping to internet? Now I am going to remove the console of internet router as well, because it is not required, right? Even distribution layer switch is also not required, but leave it. So from R1, can I ping to internet router public IP address 1.1.1.2? Yes. Can I ping 8.8.8? Can I ping 8.8.8, guys? No. Why? Because route is not there. Yes, route is not there. So we can configure one default route here. Let me configure IP route and 0.0.0, and next hop IP address exit interface is f1/0 and next hop IP 1.1.2. Now can I ping 8.8.8? Yes, you can see ping is working. Can PC ping 8.8.8? Can PC ping 8.8.8? Why? Why PC is not able to ping 8.8.8? And where traffic is getting dropped, guys? Which device is dropping the traffic? See, I am getting destination host unreachable error. That means my default gateway is dropping the traffic. Why default gateway is dropping the traffic? Because default gateway don't have route to reach 8.8.8. Right? Like from PC, when you will ping 8.8.8, what will happen? Source IP. Source IP will be the IP address of PC 192.168.10.1. Destination IP will be what? 8.8.8.8. It will forward to their gateway, right? Their gateway is going to compare destination IP address with routing table. So IP route, but in the routing table you can see no any route is available. Even default route is not available. So we have two options. Either we can configure one default route here on this router, and we can advertise default route in OSPF from router number 1. So guys, it will be better to redistribute default route in OSPF, because reason, I can have multiple distribution layer switches. So configuring default route manually on all switches can be again lengthy task. So better to advertise default route from R1. So whenever you will change the default route, whenever you will configure like any special requirement on R1, it will be automatically redistributing. So go to R1 and go to router OSPF process 1 and say default information originate, right? After running this command, again you can check the switch distribution layer switch routing table, and this time you can see I have default route, right? So now if PC will try to ping, you will get different error. This time you are getting timeout error, right? That means I'm not getting reply message. If you have access of internet, you can check that your ICMP request message is reaching to internet. Here I can say debug IP ICMP, and now let me try to ping 8.8.8. So you can see internet router is generating the reply message, right? ICMP echo reply, source 8.8.8 and destination 10.1, 192.168.10.1. The issue is route is not available. So IP route is not available in the routing table of internet router, right? Here we can change the host name also. We can say internet, or we can say ISP1, and right there. Done. So users are able to send traffic to internet, but internet is not generating the reply message because internet router don't have routes. So guys, before forwarding the traffic to internet, we have to configure NAT. By the way, you know, on the ISP router, you will have access control list. Which access control list will be allowing only this subnet? Config T, access list number 10, and permit 1.1.1.0, wildcard mask 0.0.255, right? And access list number 10, deny any. All the traffic is rest, all the traffics are denied. Only this subnet is allowed. Means internet router can receive traffic from this subnet only. Right? So this way we will have access control list on router. Do show access list. So you can see with sequence number 10 we are permitting this subnet, right? So if router 1 edge router will generate traffic with source, let's say 2.2.2.2, it will not match in this entry, then it will check this entry. In this entry we are denying everything, so it will deny the traffic, right? So now we can apply it on F0/0 IP access group number 10 direction in. So this way ISP is going to configure ACL, right? Now even if you will send the ICMP traffic, debug IP ICMP, it will not generate reply. So see, from the PC4 again I am going to ping. This time you can see what it's saying, unreachable, right? So on all and close the console and let's configure the NAT on router. Guys, to configure the NAT, first of all you have to define the inside interface and outside interface, right? So you can see my F0/0 is inside or outside. 0/0 IP NAT inside. This is my inside interface. Then interface F1/0 is my outside interface, so I will say IP NAT outside. And now I will configure the NAT. You can configure the dynamic NAT, you can configure the PAT. For the specific purpose to provide remote access to server, will configure the static NAT later. For now let's configure dynamic NAT. So guys, first thing to configure the NAT rule is match the traffic. Which traffic you want to translate, right? So you have to define the source. You have to make source as an interesting traffic. How we can do it? We can do it with the help of access control list. With the help of access control list, we can specify the traffic, like which source this router need to translate. So I'm saying access control list, let's say number 10, and the permit 192.168.0.0, 0.0.255.255. So all the LAN subnet will match in this entry, yes or no? All the LAN subnet will match. VLAN 10 also, 20 also, and 30 also. Now I'm going to configure NAT here. So again, for the dynamic NAT, first of all you need what? Pool of IP address. So you have to create one pool. Say IP NAT pool, and the name of pool. Name of pool is, let's say, ccnp. Just is a name, you can give any name. Then a starting IP address. A starting IP address in the pool. So let's say 1.1.1.10 is the starting IP address, and end IP address, let's say 1.1.1.12, right? Means two IP addresses are there in the pool. Means two user can access internet at a time, right? Then it is asking for the net mask. So we can define the net mask, or we can define the prefix length. Prefix length is, let's say, 24, like this, right? Now finally we need to add the NAT rule. This is, we have created the pool, that's it. Do so IP NAT pool. So IP NAT pool. So run, we can use then section NAT, or we can say pool. This is the command, right? Now to add NAT rule, again you will use command IP NAT, then inside. So I'm saying match inside network from the access list number 10. So IP NAT inside, and then you can see, you can say source, right? So source, and then from where it will match the source, it will match source from the access list. So I am going to use list option here. List number, access list number 10, and after that it will translate to the pool. Which pool? Name of your pool, ccnp. That's it. Enter. Got it, guys? So run NAT. So yeah, run and section NAT. This is my configuration. I have created the pool. In the pool I have defined two public IP address, and after that I have added the NAT rule. Now let me try to ping 8.8.8 from PC, and this time you can see I am getting reply yes or no. On the router you can check so IP NAT translation. So here is the translation table, right? You can see inside local IP address 192.168.10.1 and inside global IP address 1.1.1.10 first IP address, right? And outside local, outside global is same 8.8.8. Now from this PC I am keep pinging to 8.8.8. See, ping is working. From PC number 6 means from VLAN 20 also I am going to ping 8.8.8, ping 8.8.8 hyphen T. It is also able to ping, right? So on this router now your both IP address is occupied. This public IP address is occupied with this private IP address, and this public IP address is occupied with this private IP address. So if PC5 will try to access internet this time, ping 8.8.8.8, it can't. How it is able to access internet? How 3 PCs 12, but the next PC cannot access, like PC7 ping 8.8.8.8. You can see reason. On the router 1 you can like debug NAT, debug IP NAT, and then we can say detail, and you can see the translation. So here you will get error, no port list, now I am going to annul it. Protocol 1 means ICMP. Right, and it is deleting the entry as well, right? Once user will stop sending traffic, it will delete the entry. Here is your translation. Some more verification commands are there, like so IP NAT, and we can check dynamic, sorry, notepad, dynamic, and here we can check statistics. So this is the statistics about the translation. Here is the output. Total active translations, static 0, dynamic this one, extended. Outside interface is this one, inside interface is this one. Hit, total number of hit, miss my like drop packet is 0. SAP, it is taking SAP, dynamic mapping, inside pool number this like the configuration you can check in detail. So this is what, this is PAT configuration. So here I have one issue, like only 3 users are able to access internet at a time. Now what we can do, we can configure PAT here, right? So guys, to configure PAT, I am going to remove dynamic NAT. Do so run section NAT, and I will remove the pool. Say no to this pool. Not able to remove the pool. Why? NAT is in use. Because NAT is in use. NAT is using this pool right now. So that's why you are not able to delete it. So do clear IP NAT, and then we can say translation star, and now you can see I have removed it. Now we have only this NAT configuration, so we can remove this one also. Say no to this, and let's configure PAT. Guys, to configure PAT, see the command again, IP NAT inside source. I will define source from list number 10, and this time destination, like the translation IP address, will be the IP address on interface fast Ethernet 1/0, right? Means it will match source from the access list number 10, and it will translate the source into the IP address which is running on interface fast Ethernet 1/0. And then to enable PAT, you can say overload keyword. That's it. Right? Now all the LAN users can access internet with the help of single public IP address. Again here you can see ping is working. From this PC also ping is working. From PC 6 also ping is working. And from PC 7 also ping will work. IP 8.30.30 or 20.22 20.2/24 20.254. Earlier IP was not assigned there, but even if you will configure the IP, then also only 3 users can access internet at a time. Now all the user can access internet at a time. Done. Clear? Is it clear to all? Clear? Now let's say for an example, this PC 9 is one server and I want to access it from the internet. Like from internet right now, see, from the internet, can I ping to PC? Ping 192.168.10.1. No, ping will not work. The reason? Route is not there, right? But PC 9 is, let's say, server, and I want to access this server from internet, right? Let's say here I have one application and IP address of this machine is, let's say, 30. For an example 10, right? So for 30.10 I want to configure bidirectional NAT, right? So I need one public IP address for one private IP address. So let's say for this IP address, my public IP address is 1.1.1.10, private 192.168.30.10, and public 1.10. So how I will configure the static NAT? This is for static NAT. Static NAT. On R1, I can make one entry like this: IP NAT inside. This time source is not list. This time source is static, right? This time I'm saying source static, and we have one more option, that is route map, right? We'll see the use of route map when I will have connectivity from multiple ISP. Okay, so IP NAT inside source, this time I said source is static, right? So if source is static, then you have to define the IP address. What is the IP address of source? So IP is 192.168.30.1, right? Then inside global means your public IP address 1.1.1.10. That's it. 30.10, sorry, 30.10. Done. Now let me configure IP on this PC and let me try to access internet. 30.10/24 192.168.30.254. Ping 8.8.8.8. Yeah, I'm able to ping internet, and let me ping PC from the internet, right? So to which IP address I will ping? If I want to access PC, I will ping to public IP address 1.1.1.10, right? So you can see. If you are thinking that I am pinging to router, right? So on router you are not running bro this IP address, right? Whenever router will receive traffic on outside interface where destination is this one, it will always translate it to so IP NAT translation. So IP NAT R1. So IP NAT translation. Here you will have one static entry bidirectional NAT. We can say include 1.1.10. Here is my static entry, this one, right? So see, for this entry I don't have any outside local and outside global address, right? This is bidirectional NAT. This public IP address will be always translated into this private IP address, and this private IP address will be always translated into this public IP address. So now anyone on the internet can access my private server through this public IP address, right? So now you can share the public IP address of your server to anyone, to your employees, right? Or to the outside user. So here I can say public IP of this device is public IP is 1.1.10 and private IP is 192.168.30.10, like this way. Got it? So we have implemented all types of NAT here: static NAT, dynamic NAT, and PAT. Guys, nowadays we are not using dynamic NAT. Static NAT is in use and PAT is in use, both. Clear? Clear, guys? Is it clear? Now I am going to add one more ISP for redundancy here. Here I don't have redundancy, so I am going to add one more ISP. So let me use one router. Let's say it is ISP 2, and let me change the symbol also. this way. On both the ISP, we have 8.8.8. And like 8.8.8, we can have multiple subnets, like we can say 8.8.8 as well as 1.1.1. Here also 8.8.8 and 1.1.1, like this way. Here this side, let's say I am using subnet 2.2.2.0/24. So now how to configure the NAT? So now guys, see, we can have two types of requirement. First type of requirement can be, this is my primary ISP. First requirement will be this, one will be your primary ISP and another one will be your backup ISP. So let's say this is primary and this one is secondary, backup. Got it? Second requirement can be load sharing. I want to achieve load balancing between ISP1 and ISP2. So for load balancing, you have to configure BGP, and for primary and secondary scenario, you can configure default route. Both will work. Got it? Till then, I am going to save the internal devices configuration so that we should not configure it again. Okay, and then like this we'll create one another side here, and then after that we can connect all the ISPs together, and then we'll see the VPN between router 1 to router 2. Okay, so this will be my topology for next class. Tomorrow we'll configure both scenario, primary and backup, as well as load sharing. Okay, so that's all for today guys. If anyone have question, please ask.